Hello children, how are you all? Hope you all are doing well. This is Krishnamurthy. You can call me as VKM, working as chemistry faculty at Basidia. In the previous lecture, we had discussed about preparation methods of amines along with few organic conversions. In this session, we will be talking about few organic conversions as well as physical properties of the amines. All these conversions are from your NCERT in textual questions only. And these conversions will give you a clear-cut idea to do most of the conversions which are there at the end of the chapter. Let's make a look on it. The first question they gave, write chemical equations for the following reaction. A, that is one reaction of ethanolic NH3 with C2H5Cl. Reaction of ethanolic NH3 with C2H5Cl in the sense ammonolysis of alkyl halides. NH3 I can write it like that. Then HCl can be removed. It gives you C2H5 NH2, which is on further treatment with C2H5Cl gives you C2H5 NH C2H5, that is N-ethyl ethanamine. N-ethyl ethanamine treating with C2H5Cl, which gives you C2H5 N C2H5 C2H5. It is N, N diethyl ethanamine, which is upon further treatment with C2H5Cl. This lone pair will be given to this. You will get C2H5 4 times N plus Cl minus. This is quaternary ammonium chloride. Quaternary ammonium chloride. Quaternary ammonium chloride. We got finally quaternary ammonium salt. Initially we got a primary amine, next secondary amine, next 3-degree amine, and finally we got 4-degree salt. That is the question, and as per the question this is the solution. Next, ammonolysis of benzyl chloride and reaction of amine so formed with 2 moles of CH3Cl. Benzyl chloride, part 2 they gave. Benzyl chloride, what is the formula? C6H5CH2Cl. Ammonolysis, that is with ammonia, it gives you C6H5CH2NH2. A primary amine is formed. And they said with 2 moles of CH3Cl. So take 2 moles of CH3Cl and these 2 hydrogens and 2 chlorines are removed as 2HCl, and we get a product that is C6H5 CH2 NCH3 CH3. It is N, N dimethyl benzyl amine. N, N dimethyl benzyl amine. It is the product can be formed. A tertiary amine you can say. Hope you understand that. Next question. Write chemical equations for the following conversions. First one they gave CH3CH2Cl into CH3CH2CH2NH2. It is another example of organic conversion. CH3CH2Cl should be converted into amine. But if you observe it, here 2 carbons, here 3 carbons. Such type of reactions are said to be ascending series of reactions. Carbon number is increasing. So it should be treated with KCN, and then you get CH3CH2CN. I have introduced one more carbon. Whenever there is a need of introducing a carbon, then potassium cyanide plays a key role to introduce that. Okay? Treat it with lithium aluminum hydride, reduction of nitriles. In previous session we had discussed. So you get CH3, CH2, CH2, NH2. This is called a primary amine. Next we have C6H5, CH2Cl. The similar way KCN, C6H5, CH2CN. Treat it with LiAlH4. It gives you C6H5, CH2, CH2, NH2. A reduction will give you the amine. Hope you understand that. So this is the way of converting one substrate to the another substrate. Next, write structure and IUPAC names of the amides which gives propanamine by Hoffman bromide reaction, and second one, the amine produced by Hoffman degradation of benzamide. First one they gave, write structure and IUPAC names of the amides which gives propanamine, right? So Hoffman bromide reaction is nothing but it is degradation. It's a degradation, like a 4-carbon compound can be converted into 3-carbon. We have to get the propanamine, right? Propanamine means 3-carbon. So 3-carbon amine. We should take 4-carbon amide. What is that 4-carbon amide? The 4-carbon amide should be butanamide. It should be butanamide. Okay. So structure is CH3, CH2, CH2, C double bond O, NH2. So it is the structure can be given. And the name is butanamide. Hope you understand that. Okay. Next, they gave another question also. What is that? The amine produced by Hoffman degradation of benzamide. So benzamide, that is C6H5, CO, NH2. That simply CO, remove it with Br2 plus NaOH, which gives you C6H5, NH2. This is called aniline or benzene amine. Aniline or benzene amine. That is the IUPAC name can be given. Okay. So these are the examples of the conversions. These are the examples of the conversions which are your NCERT and in-textual questions. Next concept we have is physical properties. What we have? Physical properties. First one is odor. That is smell. Okay. These generally lower aliphatic amines. Lower aliphatic amines, these are gases actually, but with fishy odor. With fishy odor. Lower aliphatic amines are like pungent smelling compounds which are of bad smelling compounds, right? Or fishy ammonical odor you can say. But when number of carbon atoms increases, that smell goes away. Okay. And next, if we see that physical state, with 3 or more carbon atoms, generally if you take it, 3 or more carbon atoms are generally liquids, but still higher ones. Okay. Still higher ones are there. Those higher ones are, solids. Very lower aliphatic amines are gases. 3 or more carbon atoms are there. Those are liquids, but still higher ones are there. Those are said to be solids. And if you see the, color of the compounds, aniline and other aryl amines, whichever the aromatic amines we have, so those are usually colorless. Usually colorless, but they can develop the color due to atmospheric oxidation. They develop the color due to atmospheric oxidation, but they are generally colorless. If you store them, because of atmospheric oxidation, they can develop color. And now the most important physical property we are going to talk about, it is solubility. It is solubility. Organic compounds being covalent, they are insoluble in water generally. But certain organic compounds, though they are covalent, they can be soluble in water. That is possible because of hydrogen bonding. So I can say lower aliphatic amines. Lower aliphatic amines are soluble in water. Lower aliphatic amines are soluble in water due to hydrogen bonding. due to hydrogen bonding, you can say. But that solubility decreases as number of carbon atoms increases. As number of carbon atoms increases, solubility decreases. Solubility decreases because it is due to increase in size of hydrophobic alkyl part. Hydrophobic alkyl part. If carbon atoms are increasing in the sense chain length is increasing, alkyl group is increasing, right? So that alkyl group is increasing in the sense hydrophobic part is increasing, so solubility decreases. These lower aliphatic amines only are soluble in water due to hydrogen bonding. But when we talk about primary and secondary, these primary and secondary amines are well engaged in intermolecular hydrogen bonding. Those are well engaged in intermolecular hydrogen bonding between the nitrogen of one atom and hydrogen of another molecule. Yes, primary and secondary amines. But tertiary, which is less associated with hydrogen of the water molecule of another one, right? So which have less hydrogen bonding capacity compared to primary and secondary. So solubility of these amines can be explained with the help of hydrogen bonding. With the help of hydrogen bonding. Now, if you observe that tertiary amines, these tertiary amines do not have intermolecular association. Do not have intermolecular association. Do not have intermolecular association due to the absence of hydrogen bonding. Due to the absence of hydrogen bonding. But primary and secondary have intermolecular association. How? RNHH. This is primary amine. And this nitrogen can form intermolecular hydrogen bonding with another amine. So if I take, it is primary amine, right? If I take secondary amine, RNR, and it is H. This can form hydrogen bonding with nitrogen of another amine. So it is secondary amine. So primary amine and secondary amine both they get associated. Both they get associated with the help of hydrogen bonding, but tertiary amines they cannot associate. That is the reason boiling point of these tertiary amines is very less. So order of boiling point can be given as primary greater than, secondary greater than, tertiary. Primary greater than, secondary greater than, tertiary. Why primary amines are having higher boiling point in the sense, what do you say? Because primary and secondary amines are associated with the help of hydrogen bonding. That intermolecular association is present in primary and secondary amines, but whereas when it comes to tertiary amines, that intermolecular association is not possible because hydrogen bonding is absent. There are no hydrogens in tertiary amines. Hope you understand. So it is the boiling point order. Primary amine has higher boiling point than secondary than tertiary. Is it clear? Next, sometimes they will ask a question like in such a way that out of butanal, butan 1-ol and butan 1-amine, which is soluble in water? Like which is more soluble in water? Which is more soluble in water and why? This is a question raised to you. Try to answer it. Butan 1-ol and butan 1-amine, which is more soluble in water and why? So obviously butan 1-ol in the sense CH3, CH2, 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 OH. Butan 1-amine in the sense CH3, CH2, CH2, NH2. Both are soluble in water. Both they can form hydrogen bonding, right? But which hydrogen bonding is stronger? OH formed hydrogen bonding is stronger because oxygen is most electronegative. Nitrogen is less electronegative. Hence, this is more soluble. Moreover, that compound is more polar compared to amine. This alcohol is more polar compared to amine. So, it is more soluble compared to amine. So, butan 1-ol is more soluble than butan 1-amine. It is because of polar nature of that alcohol, and moreover, extent of hydrogen bonding is maximum in butan 1-ol. Hope you understand. That is the alcohol. So alcohols are more soluble than amines in another way. Sometimes they'll ask a question like, if I take ethylamine. Ethylamine is more soluble in water. Ethylamine is more soluble in water. While aniline, is not soluble. While aniline is not soluble. Why? Can you guess it? Ethylamine is more soluble in water while aniline is not soluble. See, ethylamine in the sense C2H5NH2. Aniline in the sense C6H5NH2. It is also having two hydrogens, it is also having two hydrogens. But ethylamine is more soluble. See, in ethylamine, hydrogen bonding is present. But in aniline, if you talk about it, children, though it has two hydrogens, because of this bulky hydrocarbon part, that bulky aromatic ring, because of it, what will happen? The extent of hydrogen bonding decreases. Which makes the molecule to less soluble in the water. Hence, aniline is less soluble compared to ethylamine. Hope you understand. All these are the physical properties of amines. When we talk about the physical properties, majorly we will think of solubility and boiling points. Solubility, they can soluble in water, but which is more soluble in water? Whichever can form maximum hydrogen bonding, that can be soluble in water. More soluble in water. And boiling point in the sense, primary amine has more boiling point than secondary than tertiary, because primary and secondary are associated with the help of hydrogen bonding, but tertiary does not have such association. Hydrogen bonding is absent in it. All these are the physical properties, and we'll catch up in the next session with chemical properties of amines. Until then, take care, bye, and thank you.